So our first speaker is, one of my personal mentors, Dr. Sean Smukler. So Sean is the chair of Agriculture and Environment, associate professor and associate dean of graduate and postdoctoral studies for the Faculty of Land and Food Systems at the University of British Columbia. So as a side note, when I did my master's in soil sciences at UBC, I worked really closely with Sean, who is one of my co-supervisors. And he really pushed me to make sure the work I was doing was applied and going to have some impact beyond just those publications. So it was really inspiring to work with Sean. And the focus of Sean's research is really on helping farmers adapt to climate change and improve the sustainability of their farming practices, specifically as it relates to soils. And today Sean's going to be talking about some of the work he's been doing over the last few years with many of his graduate students to map changes in carbon in both woody vegetation and soils in the Fraser Valley. So Sean, before throwing it to you, I'm just going to look at the results from our poll. So not sure if everyone can see that. They can? Okay, thanks, Shauna. But what we can see is we have a lot of folks from government, and then we have some folks from industry associations or consultants, so that's great. That's about 24%, and some research scientists and 12% producers and some students. So it's a bit of a mixed bag. So I think that's great attendance. We have 81 people and 87 total participants. So yeah, I think we got a good mix of people there. So Sean, I'll throw it over to you to get us started.
Great. Let me share my screen. See my screen okay? Good. All right. Well, it's a great pleasure to be with you this morning. Although I am bummed not to be able to see your faces. Luckily, I can see Shauna and Shabtai and Jason in my screen. But yes, thanks for joining this morning. So as Jason said, I'm going to be talking about changes in carbon across the agricultural landscape of the lower Fraser Valley. So over the next 20 minutes, I'm going to introduce why we want to value carbon in our agricultural landscapes. And I'm basically going to be then presenting 4 studies that were funded in part by the BC Ministry of Agriculture. And the first study is basically a mapping exercise of soil organic carbon and an evaluation using remote sensing to assess how carbon has changed from 1984 through 2018. Then I'm going to be comparing some of the results by particular in-field beneficial management practices and seeing what we can learn there. And then I'm going to look at another study by another graduate student looking at field edge beneficial management practices and how these influence carbon across the valley and how we might better map those in the 4th and final study. So just to put things into context, Canada's made some very ambitious greenhouse gas emission reduction targets. So you can see here is our reference emission pathway. And you can see here in gold, this is our target for 2030. Basically, we're going from 815 megatons of emissions to 511 megatons of emissions in less than 10 years. It's pretty ambitious. Now, when we look at our 2050 target and we rescale the axes on this, you can see our 2050 emission target is extremely ambitious. So we're basically trying to get to a zero carbon economy in less than 30 years. So we have a long way to go, and basically all sectors are going to need to participate in how this happens. So this is a graph from the last British Columbia emissions report. And this is showing that our total emissions is 61 megatons. And agriculture is a very small part of the total emission pie here. So in 2012, we were only producing 2 megatons, and this is roughly 3% of the total emissions. But here are our provincial targets. We want to reduce 40% by 2030, 60% by 2040, and 80% by 2050. So again, these are extremely ambitious targets, and it is a situation where we all are going to need to participate. So what does that mean for agriculture? Well, what we need to do is find pathways towards those emission targets that are going to be not only beneficial for the climate, but beneficial for producers. So what we're looking for is win-win beneficial management practices. So one of the potential pathways for this would be to increase soil organic carbon through practices like cover crops or grassland set-asides, a project that Jason worked on in his master's work. Or we could be looking at field edge management. So we could be planting hedgerows or riparian buffers on the edges of our agricultural fields, or we can be conserving them. This is a situation here where we see over a period of 5 years, basically deforestation on the edges of our agricultural fields. So we know that there are a number of benefits of soil organic carbon. We know that it improves infiltration, water holding capacity, helps cycle nutrients, improves the tilth of our soil, helps increase the resilience of our farming system, and overall contributes to a healthy crop. And the global community is starting to recognize that this is an important win-win situation. In 2015, at the Convention of Parties in Paris, there was an initiative started, this 4 per mil initiative, that basically recognized that of the 40 gigatons of emissions globally that we have a year, 22 to 35 of those could be sequestered in our agricultural or in our soils around the world if we increased what is the current concentration of soil organic carbon by just 0.4% per year. So a very small incremental increase could almost offset global emissions annually. So of course, this is a back of the envelope calculation. It needs a lot of work, but it's gained a lot of momentum and a lot of excitement among policymakers, among those of us who are working in this field. So let me talk about the work that we have been doing in the Fraser Valley. So this first study that I'm going to present is by a former graduate student, Siddhartha Paul, who mapped the organic carbon across the valley in 2018. So Sid and a crew of students sampled 310 locations across the Fraser Valley, the lower Fraser Valley, making sure to sample among different land use, land cover types. And Sid used a really interesting methodology where he took Landsat imagery, climate data, existing soil survey data, and digital elevation model data, and integrated these using a statistical machine learning approach, and developed land use, land cover maps for various years from 1984 all the way through 2018. And then from that derived soil organic carbon maps. So let's look what he found. Here's a map of the land use, land cover of the Fraser Valley at 2018. And here's the change map from 84 to 2018. And you can see there's not a huge amount of change across the landscape. And then when we map the soil organic carbon, we see that he did a fairly good job. I'm not going to show the validation statistics here, but he did an exceptional job in mapping this carbon. And some of the results clearly mapped onto what we expected in the landscape. And the changes that we saw were consistent with what we would expect, except that it was a little more extreme than one would want. So this is a distribution of the change in soil organic carbon from 84 to 2018. And across this landscape, we saw that 20% of the soil organic carbon was unchanged, 61% was in decline, with only 12% increasing. And what's concerning is by calculating the overall carbon at the 0 to 15 centimeter depth using a standard bulk density, we estimated that it was about 5.8 megatons of CO2 that was lost during this period. And that's about 2.5 times BC's annual agricultural emissions. So when we look closer at where these losses were, we saw that it really was in annual crops that were continually being managed for agriculture. So this is showing the change relative to this zero line in terms of percent change over that time period. And these box plots are illustrating the distribution with the black dot here as the mean distribution of the pixels across this landscape. So in some cases, we see that there were gains, in some cases, much higher losses, but overall the mean was showing losses. We did see some potential, the highest potential gains were in annual grasslands and in the switch from annual crops to perennial crops. So we see that in these two agricultural categories, we see the greatest potential gains. So in the next study that Sid was also working on, we looked at specific management practices. So in particular, beneficial management practices of winter cover crops and grassland set-asides. So we could do this because we had a very detailed inventory from the Delta Farmland and Wildlife Trust. They've been promoting these practices since 1992. And so here we've mapped out basically the fields that have grassland set-asides and winter cover crops in different concentrations over the years, and compared those to perennials and annual crops in the region of Delta. So unfortunately, we just had this data for Delta only. So this is the distribution of those different practices. And we see from 84 to 2018, there overall wasn't that much change in the landscape. And again, we mapped the soil organic carbon and the changes in soil organic carbon. And this is showing the distribution of fields in those different practices. So what we're seeing here is perennial berries. So this is blueberries, for example, have the highest mean organic carbon and the highest overall potential. So some places in that landscape have very high perennial soil organic carbon. But what's concerning is that all of these fields that had these beneficial management practices aren't actually resulting in great gains. And in fact, we're seeing clearly losses across the entire Delta region, despite the implementation of these BMPs. So this is concerning, and we're certainly digging into this data set deeper. We need to better understand and validate this information. So the third study that we looked at was conducted by my graduate student, Lindsay Dowell, who's graduated now and works for the Nature Conservancy. So she sampled, she was looking at the value of carbon in hedgerows and riparian buffers, these field edge management, beneficial management practices. So again, same study area, sampled all across the valley. In this case, she sampled soils down to 1 meter and the above ground vegetation. She had some very interesting results. So this is showing the soil organic carbon for woody riparian buffers, high diversity hedgerows, low diversity hedgerows, compared to managed grasslands and annual crops. And what we see is that there are significantly greater concentrations of soil organic carbon at the 0 to 15 centimeter depth in these practices, which is what we would expect. The real difference is actually in the biomass, though. This is showing the mean and standard error of the biomass that she measured in the hedgerows and the woody riparian buffers compared to the neighboring fields. But what's important in her analysis is this fourth study is trying to be able to track these changes remotely. So this is a Landsat image that Sid used in his analysis. And this is showing what that same landscape looks like with the riparian buffer here and some hedgerows, illustrating by a very high spatial resolution imagery such as worldview. This is very expensive imagery. This is freely available. We took a medium resolution or a high resolution medium cost imagery and analyzed this for changes. So she basically did again a statistical model to look at how changes occurred over time. And she quantified the density of hedgerows on the left here and the density of riparian buffers on the right, and quantified how much carbon was being stored in those BMPs. 1.4 megatons, a little more than half of the emissions. Well, yeah, 60%, roughly 60% of BC's agricultural annual emissions. And then she did an analysis of change over time. And there's some good news stories out there where the density of hedgerows is increasing, and then some bad news stories where the density of hedgerows is decreasing, representing additional emissions, but also a potential to sequester more if we're planting across the landscape. So the bad news is that we have substantial areas in decline in terms of soil organic carbon across the Fraser River Valley. But this also represents a sizable potential to capture that carbon back. So as I said, this is that 5.8 megatons represents 2.5 times the BC, not 2.5%, 2.5 times the BC agricultural annual emissions. And our preliminary results show that grassland set-asides and winter cover crops aren't necessarily increasing soil organic carbon over the long term. So we really do need to identify practices that are in field that can reach this potential that we're talking about. And then hedgerows and riparian buffers do clearly have an opportunity here to increase the carbon across the landscape. And right now they represent about 60% of BC annual emissions. And we could imagine that by planting hedgerows and riparian buffers across the landscape, we could help meet those very ambitious targets that we've set out. So the next steps, we need to do some more detailed analysis into those in-field BMPs, and then some further refinement of this remote sensing-based monitoring of hedgerows and riparian buffers. So this work, of course, is definitely attributed to Sid and Lindsay, and funding from the BC Ministry of Agriculture, as well as NSERC, and a whole suite of other people from my lab. So I'll open it up now to questions. Thank you.
That's great. Thanks so much, Sean, for that awesome presentation. As you're presenting, I was just thinking back to 4 or 5 years ago, being in the field with you, Sid and Katie, and flying a drone around and collecting samples, and seeing where that started to where you're at now is pretty impressive and amazing to see the whole story come together. So that was really, really great. We do have quite a few questions. Actually, before the question, I saw that there was a comment that said, this information would be important to share with Metro Vancouver regarding their Climate 2050 strategy. So this could be pretty timely with some of the work that's going at the local government regional district level. And I'm sure you're probably already tied into that, Sean, but just a note that was put there. The first question that we had was wondering, I guess, and asking if you saw any changes in soil organic carbon that were related to integration of livestock into the landscape.
Yeah, that's a really interesting question. And I actually, a graduate student whose results I didn't present here, that Kent Mullenix and I co-supervised from my lab in Kwantlen, did that type of, asked that question in the Alaxon Wildlife Reserve, where they actually do integrate animals into the rotation. And Grace actually did see increases in soil organic carbon in the systems that had animals integrated in the pasture system, as opposed to the rotations that did not have animals.
That's very interesting, and maybe something further to explore with all the talk of regenerative agriculture that we've been hearing recently, and definitely ties into that piece. So another question that we have here, I'm just looking at the ones that are getting lots of votes. Hedgerows and riparian buffers represent a net benefit, but wouldn't the benefit mostly be a one-shot affair because the bulk of the carbon is related to vegetation above ground, not soil carbon? So I guess looking at that carbon dynamic there.
Well, I mean, both in terms of the above ground and below ground carbon, there's going to be a maximum that you're going to reach in the system. So what we're talking about is a near-term approach. So, you know, if we plant a hedgerow today, it's going to get to that maximum benefit in 15 to 50 years, and it's not going to increase carbon after that. But what we're looking for right now is near-term solutions. We are, as a society, we're hoping that there's going to be this great technological fix to get us through this problem. And in the meanwhile, we need solutions that we can implement today. And these are solutions that can buy us time as we're trying to get to a non-carbon-based economy.
Yeah, and I think relating to this, we have another question that follows up nicely. And what is your sense of working with farmers and how they value soil organic carbon or soil organic matter in their operations? Do you find that it's a fight to convince them to change their practices? Or is there more we could be doing, I guess, as a society to promote that?
I think there's certain, I mean, the issue is that many of the practices that we promote aren't necessarily doing the job that we're expecting. So take cover crops, for example. We're promoting cover crops widely, but you know, many farmers in the Fraser Valley have a really hard time either getting them established or keeping them established over the course of the winter. As you know, a lot of them just get devoured by migrating waterfowl. So, you know, there are alternatives to cover crops to getting carbon in the ground, and I think to promote those, we do need to see this as a shared challenge. It's not just a challenge that the farmers should be facing alone. This is if they're going to be part of our society, the biggest societal problem that we face today, they need to be supported in that.
Yeah,
by all of us.
Thanks for that, Sean. I think we have time for one or two more here, just looking at our screen. So what I'm seeing here, a good question here, maybe just outside that Delta region, but one of our attendees noted hedgerows are decreasing in the city of Abbotsford area, where farm gross receipts have been increasing, and hedgerows are increasing in the township of Langley, where farm gross receipts have been lagging. So interesting patterns there. Do you have any suggestions for being able to increase hedgerows and still maintain a trend of increasing farm gross receipts or production?
Yeah, I mean, I think again, this is where that shared approach to the problem might help. You know, we're expecting farmers to maximize their production, to make their economic bottom line sustainable. If we're asking them to reduce the amount of land in production, maybe we should share in that cost.
Yeah. And maybe we'll just do one more. Looks like we have, well, this question, I think I'm going to reword it a little bit. But is there any, you know, have you noticed with any specific crop types or any specific commodity groups that they're actively adopting practices or shifting their practices to increase soil organic carbon? Like, does one stand out more than the other? Or you find that most producers are trying to do what they can in that regard?
Yeah, honestly, I don't have enough of a pulse of the farming community to answer that one. But I think it's a really good question. And I think what I hope that we do as a network is identify those producers that really are doing a great job and highlight the work that they're doing, and you know, help them share their stories so that we can promote this widely. Because for sure there are some farmers that are doing a great job, and they need to be made examples of.
Yeah, and it was interesting in the work you showed, it seemed like perennial crops just naturally tended to sequester more carbon. Is that what you were seeing with was that blueberry farms, would you say, or what are you thinking there?
Yeah, so Yeah, those are blueberries. So there's above ground vegetation there. There's a lot of inputs. There's sawdust being applied to many of those fields, and there's not much tillage that's happening. So those are all promoting soil organic carbon. But I mean, one thing that I didn't mention here is that, you know, we have to do the full accounting on these systems, that these systems are also producing other powerful greenhouse gases besides CO2. And the net accounting has to be negative, right? We can't just count carbon. We have to monitor the nitrous oxide and methane emissions as well.
That's interesting. Okay, so I think we do have a few more questions, and Sean, if you want to go in the background and answer some of those, you can. There's also opportunities later on for us to get to those, but we'll move on to our next presentation for now. So the next presentation, we have both Shabtai Bittman and David Poon, who will be co-presenting on their research, which is looking at nitrogen and phosphorus inputs, outputs, and internal flows in the lower Fraser Valley, as well as possible future directions for circular nutrient cycling. So this is a really hot topic right now, as we do have the recent agriculture and environmental code of practice that came into play last year. So that's had some pretty significant impacts for producers in the Fraser Valley. So this is a very relevant topic right now, and I'll start off by just introducing both speakers, and then we'll jump into the presentation. So Shabtai, I'm sure many of you are familiar with Shabtai, has been working in BC agriculture for a lot of years now, and he's a research specialist at the Agriculture and Agri-Food Canada in Agassiz for that Research and Development Center. His research focuses on improving agriculture systems while reducing environmental impacts, but he's really focused on strategic use of manure as a primary nutrient source, and is also interested in regional nutrient and carbon flows. And my understanding is that Shabtai will be doing the bulk of the presentation, but then David Poon will be adding a little bit at the end there. So Dave is a colleague of mine here at the Ministry of Agriculture, Food and Fisheries, and he works as the manager of the Resource Management Unit. You know, Dave has been working in agriculture for quite a few years now as well. He was the provincial soil specialist before coming into the role that he is in now. And I think over the last decade, he's done a lot to bring together farmers, researchers, public servants, and others to improve agri-environmental sustainability. So with that, I'll throw it over to you, Shabtai, if you want to upload your presentation or share your screen there. We'll get started with that. All right, perfect. See it up here.
Look all right?
Looks all right, but I think it's not in the presentation.
I'm trying.
No problem.
Yeah, okay, here it is.
Awesome, thanks.
Slow reaction time. So thanks, Jason, for that nice introduction, and thanks to Shauna and I guess the committee for the invitation to come to give this presentation, and thanks to Sean for the warm-up act for me. And of course, I want to recognize you're going to hear from David Poon. He's a co-author on this, and Derek Hunt, who's been working. We've been working together for quite a few years now, and so you're familiar with this. This is kind of an artist's perspective on what Fraser Valley looks like. It's a very nice view showing the limitations, the constraints, mountains and ocean and the US border. And it nicely also overemphasizes the foreground, the city of Vancouver. So no doubt it was drawn by somebody from Vancouver, and doesn't really properly represent the land use in the area, or the available land in the area. This is a pictorial view, and it also demonstrates a little bit what's going on in this region. So we have something like 128,000 head of cattle, and they're mostly high-producing dairy cows. And we have something in the neighborhood of 16 million chickens at any one time. And this contributes towards, with the horticultural production, towards $1.6 billion a year in farm gate revenue. And there's no place else in Canada that can produce this much farm gate revenue on just basically 55 to 65,000 hectares of agricultural land. And added to this, of course, is 2.5 million people that live in the area. And not to forget the importance of the area as a livestock, as a wildlife habitat, in this case showing the Dunlin in the Fraser River Delta, which is one of the only places in Canada where migrating waterfowl will overwinter. So it's extremely valuable and a treasure. So the Lower Fraser Valley can be categorized as a peri-urban region, and it perhaps exemplifies worldwide concerns about food security, sustainable intensification and protection of the need to protect air and water and land. And these are typical in all regions around the world where there's ever-growing cities, often located in the midst of the best agricultural land and consuming it. So this is kind of what it looks like in a more appropriate proportionality. So you can see where the urban areas are as gray and the agricultural areas interspersed throughout in the light green, and of course you can see the forest and so on. So this shows the nature of this kind of peri-urban interaction. And what I wanted to begin kind of the talk with is a presentation of this sometimes referred to as a leaky pipe model or a hole in a pipe model, and in terms of nutrient management. And this has, it's a very simple representation, but a very important one, and actually is able to identify a number of different important elements of managing nutrients. So to begin with, you have inputs coming in, and this could represent any system, by the way. It could be a field, it could be a farm, and it could be a region, it could be a country, it could be the world. So nutrients come in our case, as fertilizers and manures into the region, or fertilizer and feeds into the region. In a field, it would be fertilizer and manure, and then production is exported. So there needs to be a balancing between the inputs and the outputs. So the amount you put in has to balance what's taken out. And if you add more, you have to remove more, because if you don't, then something will leak out of the system. It has to. And the leakages are things like ammonia, a gas which has health issues associated with it, and nitrogen gas, N2 gas, which is innocuous, but nevertheless a loss to the system, nitrous oxide, and you can have leaching and runoff of nitrate. So those are all potential losses. So, so we learned that if we add more than we take away, then we will increase the losses in the pathway. But if we try to plug up some of these holes, let's say by using methodology to reduce ammonia loss from livestock operations, but if we don't change the balance, what will happen is we will get an increase in other loss pathways, say leaching. And this does actually happen in reality. So in order to get the benefit of mitigation, you have to also look at the balance. You need to do both. If you have leaks in the system, you will need to add more inputs in terms of blocking the leakages, and you need to improve the balance. So this map of Canada shows nitrogen use on agricultural lands, 2016 data. It doesn't change that much from year to year. And you can see the lower Fraser Valley over here, as you know, and it's a hotspot. It's not a very big area, but it's about as hotspot as you get in Canada in terms of nitrogen use. And so it's important, the nutrient inputs that come into this area. So we started to investigate what are the nutrient inputs into this peri-urban region. It broke it down into basically two ecosystems, the agricultural ecosystem and the urban ecosystem. And we know that we're producing food, and most of that food, some is exported, but most of it is transferred into the urban ecosystem in our area. So then we looked at the inputs, we looked at the outputs, and we looked at the internal flows. And what we found was that from the agricultural point of view, the main inputs were feed to livestock, but also fertilizer. And also there was some importation of livestock, a relatively minor input. And the outputs were some sales outside of the region and some manure exports, but mostly what were outputs were actually losses into the environment, such as ammonia emissions and nitrate leaching, and a certain amount of runoff. And with the urban ecosystem, the main inputs were food that's imported and purchased and brought in, but it also includes pet food and some fertilizer for ornamental use, for amenity use. And so when you, and then of course the transfer of the nutrients from the agricultural system into the urban ecosystem, then that represents displacement of what would otherwise have to be imported from outside the region. So it's a very beneficial activity to be able to do this, but it comes with adding inefficiencies and losses through the agricultural system, and especially when it's managed so intensively as it is. So we did it, we tallied it all up, and what we found, for example, here's nitrogen, next slide will show you phosphorus, is that annually we import 41,000 kilotons, that's 1,000 tons of nitrogen into the region. And of that, 34,000 tons every year is basically lost. It's lost to the atmosphere by volatilization, it's lost by leaching and into the aquifer and by runoff and even into landfills. And so 34,000 tons of nitrogen are brought in every year that are lost. 41,000 are brought in. So what is this, how do you visualize this? Well, if you were to convert this into mineral fertilizer, say urea, which is a little bit under 50% nitrogen, and you figured out how many bags of fertilizer would be, well, basically what you could do is load up something like 70,000 one-ton trucks full of fertilizer, bring them in every year, dump them, and then the next year go back for another 70,000 truckloads, one-ton truckloads. That will give you a picture of how much material we're bringing in that we're not really accounting for. And the story is similar. It's a little bit different, but sort of the same picture with phosphorus. The amounts are lower. We have a surplus of about 7,000 tons of phosphorus. The outcome is different because phosphorus doesn't have a way of disappearing by volatilization or by leaching. So a lot of it will end up accumulating in soils, and it may be able to accumulate for a long time if you have phosphorus fixing soils. But at the very best scenario would be that it actually is a loss to a finite supply of phosphorus in the world. And the current estimates are that there's a lot of phosphorus to last for quite a few years, but it's definitely not forever. And the quality of the phosphorus is declining. And what that means is that more and more of the phosphorus contains cadmium. And cadmium, of course, is very toxic. So we don't want to be using that source of phosphorus, and we don't want to be forced into it. But once again, you're looking at, with phosphorus, maybe the best you could do is, with actual phosphorus is about maybe 20 or 25%. So you can figure bags of phosphorus, 4 times that, 24,000 truckloads a year coming in, dumping their phosphorus, and most of it just staying in the soil. And it's not without a penalty, without repercussions. So these are pictures taken actually from right near where I live. And this shows the typical view in the wintertime on a nice day, which is not so typical, but on a clear day, you usually have very good visibility of the mountains. And sadly, in the summer, especially the late summer, when the weather is finally nice, oftentimes the mountains disappear, and we've all seen that. And when they disappear like this, it's often or largely due to the presence of fine particulates, ammonium from agriculture reacting with NOx from transport and factories. And together they form these fine particulates, and they reduce visibility to the point where it's been estimated that there are millions, tens of millions of dollars lost in tourist revenue for people who come at that time of the year. They try to look around for the mountains and can't see them, and they don't come back. And it's not the only outcome. We have the problem that's well known. I'm sure most of you know about the high nitrate levels in the Abbotsford Aquifer and other aquifers. And Abbotsford Aquifer is particularly well studied, in part because of the water flowing from Canada into the US and impacting drinking water in the US. And so excess nitrogen in the aquifer is absolutely problematic, and it comes from excess utilization of fertilizer. And a recent study that we are involved with, mainly centered out of the US and the Nooksack River, but the Nooksack River, a couple of the tributaries come from Canada. And there was an examination of the nitrogen budget in Canada, US, and all of it drains into Bellingham Bay, and it's very controversial in terms of what's happening there with the shell fisheries that are run and owned by First Nations. So there's yet one more implication of all this. So we need research. We need to understand sustainable intensification due to land limitation. We need to avoid peri-urban regions becoming huge nutrient sinks worldwide. And we need to example multiple level strategies for sustainable intensification. So here's, I'm going to give you a couple of examples of what we've been doing at Agassiz over a number of years. And this is a real-time soil nitrogen model. This represents just a small part of what the soil nitrogen flow looks like in the soil. And by better understanding what happens in real time, only then will we be able to really manage the nitrogen that we put into the soil. And so we need to advance this way of thinking. And it's aided by improvements in nitrogen, or in, weather forecasting, which will greatly help it'll greatly help the farmers in making decisions about how and when to use their nutrients. Another level that we look at, that's kind of the field level, and now we can look at the whole farm. And this is a study that we did with some typical dairy farms. We looked at UBC dairy and some other ones. And what we're considering here is how to reduce the imbalance between the amount of feed and fertilizer that are brought in and the amount of milk that's exported, milk and animals that are exported. And so this is a very important part of the equation. If we don't reduce the imbalance, we won't solve the problem of leakages because it's just a simple matter of arithmetic. So that we need to take that into account, and we need to find ways of producing more homegrown feed and importing less feed, and to make better use of the manure resource, nutrient resource, and reduce or limit or eliminate even the purchase of fertilizer for livestock operations like dairies. And so here's on another level. So this is a way of trying to reconcile regional problems. And I mentioned the aquifer, and the aquifer, of course, has been getting a lot of poultry manure over the years. And that's been to improve the carbon. We heard a lot about carbon. Carbon is important. This has been the source of carbon. But there is another source of carbon, and that is separated dairy solids that has a very high C-Dan ratio. And we've done a lot of testing on it, and it's not prone to leaching at all. In fact, it may even reduce native leaching. And so the dairy farmers may be able to exchange with the raspberry farmers and take the poultry manure from the poultry farms for use on their grassland, and replace some of the nutrients that they then transfer as a high carbon to nitrogen organic supplement for raspberry fields. So kind of a win-win. Doesn't completely solve the phosphorus problem, but it needs to be, again, a solution on multiple levels. So getting to the very end here is what happens with waste recycling in the lower Fraser Valley. And we know that there's some very good manure use, some not so good manure use. Some manure is exported, usually to marginal land, and doesn't contribute a great deal to food production. Some waste is used as animal feed. There's waste to energy and incineration, waste to energy and anaerobic digestion. There's composting. There's, I'm sure, other uses. And a lot of the waste winds up. A lot of the waste winds up in landfill, partly because it's not clean enough to be used in these other activities. So just some observations on recycling. Is there a competition for carbon? For example, anaerobic digestion, composting, and what you heard about a few minutes ago was salt sequestration. There's only so much carbon to go around. And note that most of this carbon reuse is actually one-time use. It's not a continuous resource. That's different if you could recycle the nutrients. They can be reused, at least in theory, over and over and over again indefinitely. So one idea that we've been trying to work on is to try to see if there's a way to integrate the cities and the farms in terms of nutrient use and base it around anaerobic digestion possibilities with different waste products. And there are already anaerobic digestion associated with some of the wastewater treatment plants and some farms. Many of them are located close to the river. That's advantageous in terms of transport of materials because there's a lot of material transport involved in these operations. And so this is something that we're pursuing in a number of different ways now. And it's just another way of trying to resolve the problem, which cannot be solved on just one level. So in conclusion, there's a growing need for food and food security and diminishing land, and it requires that the region to sustainably intensify food production. It is necessary that imported nutrients are minimized so that losses to the environment are minimized in order to safeguard our food security and our environmental health. And greater efficiencies are needed, and they are possible with bold research to address all spatial and temporal scales. With that, I thank you for the opportunity to speak.
That's great. We thank you, Shabtai, for that excellent presentation. So Dave, we're just going to jump right into your presentation. So Shabtai, I think you're going to have to unshare your screen, and then Dave, you'll share your screen. And while Dave's doing that, just want to remind folks to pop your questions in that Q&A tab. We're running a little behind schedule, but we'll still try to squeeze in at least 2 or 3 questions there. And Dave, I'll throw it to you to wrap up this session.
All right. I hope you're seeing my right screen there.
Dave, we see
Shabtai
your
presented.
We're actually seeing your both screens.
Okay. All right.
But doesn't really, if you're good with that.
No worries. I'll, there we go. That should work.
Yeah, perfect.
All right. 3-minute epilogue, a commentary on what I've learned, how I have changed the way I see things as a result of the work that Shabtai and I did, mostly Shabtai. You mentioned phosphorus as one of those nutrients, and 10 years ago, I don't think you would have seen phosphorus really being mentioned in the lexicon of nutrient management. It was more one of those sort of almost scary things in the future. Well, today we have a regulation that is going to phase in phosphorus limits on farms, and it's going to affect nearly all farms in BC. And you see that in the press. Dairy farmers have this very much on their minds. They've been watching the soil test phosphorus levels go up year after year, and they're thinking about how they can address that. If you were to go to trade shows, you would see the fertilizer companies marketing products and services to help keep soil phosphorus levels in check. And one thing to know about nutrient management, if you're going to bring in phosphorus limits, those are much more difficult to meet than, say, nitrogen-based limits. And that's just the balance of nutrients. That has to do with the balance of nutrients in your manure. So it's a big deal that phosphorus is on people's minds, but it's an uphill battle. And we know that because of what the phosphorus balance currently is. There isn't a way to just magically snap our fingers and turn that tap off. And it used to be that I could go home back to the city of Vancouver and think, well, that's their problem. It's a huge challenge, but I can be an urbanite, I can be a city boy and not think about that for the day. But after you've been working on the study for as long as we have, two things happen. A, you just want it to be over because you can only work with Shabtai continuously for so long. And B, you start to see yourself as part of the food system. And I took this photo not just from anywhere in Vancouver, but from the Port of Vancouver, from a top West Coast reduction. That's a rendering plant. They take slaughterhouse waste, a bunch of other wastes, and they're turning it into other products that it gets special mention in our phosphorus paper. And part of the reason for that is it is one of the few examples of true recycling within the region. It's probably also why I think twice when I'm throwing my bones from my dinner plate into the green bin. That green bin is destined for composting. And unlike the products that are coming out of West Coast reduction, poultry feed being one of the big ones, that bones I'm throwing into the compost bin ends up in compost that I'm not so sure it's ending up in actually benefiting food production. Again, I point out rendering as one of the few examples in all these different flows of the blue arrow that goes from the city back into the agriculture region. There's a lot of buzz these days about zero waste, circular economies, and it's really focused on carbon. And that's great. I think we need to get there. But I hope that we have the foresight going forward to think about the other nutrients, the nitrogen and phosphorus, as we're thinking about how zero waste and circular economies are going to look in the future. Back to you, Jason.
That's great. Thanks so much, Dave, for just tying that all together for the audience. That was an excellent little addition there to the presentation. We are running pretty short on time, and I'm just going to ask one question, the one that's popped up here, and I'll actually throw it to you, Dave. It's with so much phosphorus building up in soils, what is happening with nutrient cycling that requires producers to still add more rather than using what is already there? What is binding up the P for plant intake? I know this is a technical question, but I think your master's was actually focused on this. So if you can summarize it shortly, what the issue is, what would you say?
That sounded like a multi-part question. You want to pick one?
I guess, why are producers still adding more when there's already a lot of phosphorus in the system?
Yeah, I think there's for multiple reasons for it. But let's get our minds off manure for a moment, and let's think of the potato grower and just their nutrients in general. On a per acre basis, we see more losses of nitrate from that potato system than we do in your forage corn, forage grass system, or forage grass anyway. It is a more leaky system. And there's a great paper out there, Q3, published a couple of years ago, on why it is that we keep adding phosphorus. And there's multiple answers, but one of them is that when you look at the recommendations, we haven't fine-tuned the recommendations, the science well enough in some of these systems to actually be recommending less phosphorus. The recommendation is always that they're going to respond to more fertilizer. And I think Shabtai's group has done some great work in your forage systems, or in the forage systems, to show how that response to fertilizer, what the truth is and the whole truth is behind that. So I know there's running out of time, so I'd just say, read the paper, and I think there's some really great nuggets of truth and some low-cost strategies to better fine-tune that phosphorus balance.
That's perfect. Thanks, Dave. Bit of a technical one and hard to answer in 30 seconds there, but you did a great job there. So with that, I'm just going to do a quick wrap up of the session. Yeah, I want to thank our presenters, but also all of you for joining us here today. I know we didn't get a chance to get to all the questions. One thing I just want to put a little plug in is that there is a discussion board on Padlet that Sean is going to send a link out. If you haven't checked that out, I looked at it yesterday. It's a really cool interactive kind of tool that allows us to keep this conversation going, because we're talking about some really big issues that we're going to need to be focusing on for the next decades and years. So we need to keep this conversation going about soil organic matter, about phosphorus, about nitrogen, and how we need to deal with these problems and finding solutions as we go into the future. And I do want to also put a plug that there are some other great sessions today. The next one's at 11, which will be looking at innovative practices for adapting in vegetable production. So we encourage you to join that one as well. Behind the scenes, we want to give a big thanks to the planning committee for this, UBCIT, our workshop funders, so that's the BC Ministry of Agriculture, Food and Fisheries, and other donors. And at the end, just want to thank everyone again for being here. There will be a survey just with a couple quick questions so you can let us know how it went. And we'll leave it there, and hope you all enjoy the rest of the sessions coming up. So thanks again, everyone.